Okay. Hi guys, so I'm Kelly Ellis, and in this presentation we'll talk a little bit about combinatorics in the Middle Ages. So just a little overview. We'll talk about the background of combinatorics in the Middle Ages, and we'll go into the Rhine Papyrus and the example that is actually seen in the Rhine, and then we'll go into the Sefer Yetzirah, and then we'll talk about both Abraham ibn Ezra as well as Levi ben Gershon. Now, hopefully I can say these right as we go through this presentation. Okay, so what exactly is combinatorics? So I know in my class I've seen it, or in my cases I've seen it in discrete math, as well as a couple times in my high school classes. But basically combinatorics is concerned with defining a finite or discrete mathematical system, and then solves problems related to the selection and arrangement of different numbers or items within the system. So a typical problem could be determining the number of possible configurations of a particular type. So that could be the values that might happen whenever you roll a pair of dice. That's a common one. I know I've seen that a lot in my classes, at least. And combinatorics has actually a lot of applications in probability, as well as algebra and geometry. So I've definitely seen it in probability, both in stats classes as well as my math classes. But combinatorics is an ancient branch of mathematics. So now we go into the Rhine Papyrus. So the Rhine Papyrus of Egypt is actually one of the oldest mathematical texts in existence. And we see that the 79th problem in the Rhine deals with combinatorics. So I wrote it down here and we can kind of look at it as one of the problems. So the problem states there are 7 houses. In each house, there are 7 cats. Each cat kills 7 mice. Each mouse has eaten 7 grains of barley, and each grain would have produced 7 hecat. What is the sum of all the enumerated things? So I kind of wrote it out, and there are different variations of this, so I kind of included it here, but there could be wheat or barley, so it's kind of different on how it is translated or what is talked about for each different source that I saw. So how they did this is, so we see that there are 7 houses. So we have 7 here, and we'll kind of go down the line. So then each house has 7 cats. So then 7 times 7, you get 49. And then each cat kills 7 mice, and each mouse has 7 grains of barley or wheat, as we see. And then each grain would have produced 7 hecat. So then we go down the line like that. But we also see on the right side that it's actually just growing exponentially on what 7 is raised to. So we start with houses and it's just raised to the first power. And then as we go down, it's raised to the second, to the third, the fourth, and to the fifth, until we finally get our total answer, which is 19,607. So the sum of the total enumerated things, so that would be the sum of the houses, the cats, the mice, the barley or wheat, as well as the hecat, would equal 19,607. And so we actually see that in this problem, it shows the formula for the sum of a geometric series, which we see is 1 r squared all the way to r to the n. And we see that here because n is 5 in our case. So we could have just done 7 to the 5th. So that was a pretty interesting result that came from this. So now we're going to go into the Sefer Yetzirah. And this is either the book of formation or the book of creation. And it's the earliest title or earliest surviving book on Jewish mysticism. And some have treated it as a treatise on mathematical and linguistic theory as opposed to Kabbalah. But the goal was to convey how the things in our universe just came into existence. So that was the goal in this book. There are multiple versions of the Sefer Yetzirah, including, I wrote them down here, the short version, the long version, the Sadia version, the Gra version, and there's, of course, many other versions. But one difference between them is for like the short version and long version, while the differences may seem minor, the short version is comprised about 1,300 words, while the long version is about twice that. So that's some of the differences that you might see between these different versions of the book. So exactly how is combinatorics related to this book of the Sefer Yetzirah? So in this book, it describes how the universe was created by the God of Israel, which there's a list of all the God's Hebrews names in the first sentence of the book, but it's through the 32 wondrous ways of wisdom, which I wrote them right here. So part of this is the 10 numbers, which is the Sephirot, and then the 22 letters, which is the Hebrew alphabet. So within that, there's 3 mother letters, which is like Aleph, Mem, and then there's 7 doubles, which is Bet, Gimel, etc. And then as well as 12 simples or elementals. So that breaks up the 22 letters that I see right here. So it describes in this book, it describes the 10 Sephirot and the 22 Hebrew letters in several different combinations. And the universe and man are viewed as products of combinations and permutations of these mystical characters. So in the book, that's kind of how combinatorics came into the discussion, is whenever they brought up the different combinations and permutations of these characters that were brought about from these Hebrew letters and alphabet. This kind of leads into one of the first people we're talk about, and that is Abraham ibn Ezra. So he was born in 1090 and then died in 1167. And among his numerous works were books on arithmetic and numerology, but he also had a lot of work on astrology, which came with some combinatorial aspects, which we'll actually see a little bit later. But his reason for studying mathematics is actually to get closer to God, which I found was super interesting, which we kind of see as a theme whenever I was looking through the sources for this topic. But in his book Sefer HaOlam, which is the book of the world, he discusses astrology, and he discusses the meaning of different celestial conjunctions and aspects. And it opens by counting all the possible conjunctions of the 7 known planets. And he uses systematic combinatorial reasoning to get to that. So in order to calculate the number of different sets of n elements out of the 7 planets that we had at the time, a recursive method was used. So he took partial sums of the sequence 1 through 7 with the 7 known planets, and then he took the partial sum of the sequence of those partial sums. So Ibn Ezra, next he actually found the triple conjunctions, and so I wrote it down here, but he effectively showed that 7 choose 3 equals 6 choose 2, plus 5 choose 2, plus 4 choose 2, plus 3 choose 2, plus 2 choose 2, kind of long. But that's where each K choose 2 is the sum of integers up to k minus 1. And he eventually continued in this manner with quadruple conjunctions and so on. And then he ended up finding the total of 120 for these conjunctions of these 7 known planets. So that was pretty interesting how he brought about this choose function and the combinations into astrology in this book that he wrote. So then we have to talk about Levi Ben Gershon, and he was born in 1288 and then died in 1344, so a little bit after or last person, but he was the foremost medieval Jewish mathematician. His earliest works was actually wrote it here, Masai Hashev, and that's the art of the calculator. And that is a book that used Euclidean methodology and essentially mathematical induction in order to prove numerous results in number theory and in the combinatorics. So that's how we kind of got into that. Um, so it was suspected that Levi wanted to present combinatorial results because of the Jews' interest in a topic. So Jews had for centuries been interested in the question of how many words could be formed with the letters of the Hebrew alphabet. And this also sparked the interest of Ben Gershon. So he not only answered it, but he proves important results, and he proves results about combinations and permutations of objects. So not only was he looking for the answer, but he wanted to prove answers for different questions that were going to come later, which helps us in our presence with our different probability and counting problems. So we'll see that a little later. So when you're given a number of terms, this is what he had said. When you're given a number of terms and the number of permutations of a second given number from these terms is a third given number, then that means that the number of permutations of the number following that second given number from these terms is the product of the given third number by the excess of the first given number over the second number. And so, put in more modern terms, we can say that the result said that, so m pick n plus 1, and I'm doing the permutation here, so that's where I'm getting my terminology as well as my source. So we have in our modern terms and what we see it now as, this is what he was getting at, were these two little formulas down here, which we actually take now and use in our own classes and in our own studies to find counting problems and permutation problems. So continuing on, we have m pick n plus 1, which equals m minus n times m choose n. And so that was actually, this result is actually the inductive step for proving that this next part. This is supposed to be a k, but m pick k equals m times n minus 1 times m minus 2 all the way up to m minus k plus 1. So in order to find these permutation problems, this is the formula that we will use and that we have used in our current classes and in our studies. But Levi Ben Gershon was the one that kind of like started this for us just because he was interested in how many words could be formed with the Hebrew alphabet, and this is what came out of it. So that was pretty interesting because now that we might just plug it into our calculator, we also have this formula of what it actually means to permutate something and pick. So m choose k, and then m pick k. So that is pretty much it. Then these are my sources. So you guys kind of learned a little bit about combinatorics. If you didn't already know, I have a little bit of a background on that, but got into more of the specifics with the different books and then the different people with Ben Gershon, as well as Abraham Ibn Ezra. So I hope you guys learned a little bit about combinatorics in the Middle Ages, and that is all.